So next, let's see some examples. So here it says, does side angle side, does SAS postulate justify that the two triangles are congruent? Okay, so let's take a look at number one. So we have these two triangles here, and here we have one side congruent to another. Okay, we have a second side on the first triangle congruent to the second side on the second triangle, and then we see that there's an angle that they have that's congruent in both triangles, right? And that angle is included, right? It's in between the two sides. Okay, so in other words, the two sides form that angle, right? And if that's the case, that's an included angle, and we have side angle side with side angle side in both those triangles. So the answer for this one is yes, those triangles are congruent by side angle side. Okay. All right. Number two, similar situation. We have side with side, right? We have another side with another side, and then we have angle with angle. And the angle is in between the two sides, right? It's formed by the two sides. And so once again, we have side angle side congruence. So yes, those triangles are congruent by side angle side. Notice how here they're oriented differently. Here they were oriented similarly, where this side that had one tick mark was congruent with the side on in the same position, right, in the top left, and then we had the side on the right corresponding with the side on the right, angle on the top, angle on the top. Here they're kind of flipped around, right? We have one side on the right side congruent with the side on the left, and then the side on the right in this respective triangle congruent to the side on the left of the other triangle. And so the orientation doesn't matter, right? We can flip these around, transform them, rotate them, and so what we just need is we need two sides that are congruent and their included angle, and we can say that those triangles are congruent. Okay, so it doesn't matter what the orientation looks like. All right, now number three, we have actually three triangles here, but we're trying to compare these two here and see if they're congruent. So we have one side here with one side here. By reflexive property, we have this side that they share, right? So we can say that that's congruent in each of the triangles. And then we have this angle congruent with this angle, right? So here we have two sides and an angle in both triangles, right? Two sides and an angle congruent with two sides and an angle, right? The issue is that this angle is not included, right? It's not formed by those two sides. So it's adjacent to this one, but it's not adjacent to this one, right? It's not included between the two sides. And so we can't use SAS in this case, all right? So the answer would be no. All right, so hopefully that clarifies or gives you some examples of how we can use this and clarifies how to use it. But just be careful that if you're using SAS, make sure that the included angle is congruent on both triangles. All right, so let's take a look at 4 through 7 here. So here they're asking, can the two triangles be proved congruent? If so, what postulate can be used? Okay, so let's take a look at number 4. So number 4, we have two triangles here, right? CDT and HDR, right? And so we can see that CT is congruent with HR. We can see that TD is congruent with HD. And we can see that CD is congruent with RD, right? So we have three sides that are congruent. So we can say, yes, these triangles are congruent by SSS. All right. Number 5. So in this case, we have this side congruent with this side congruent with this side. And then we don't have any other information that's given, but we can use or see a few things by looking at the diagram, right? And one of them is reflexive property. So if they share a side or an angle, we can say that, oh, well, that side or angle is congruent to itself, right? And so in this case, this line is congruent to itself, and so that gives us side, 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 congruent with side, side, side. All right, so we can say yes by SSS. All right, number 6. So here we have two triangles. We have this side congruent with this side congruent with this side, and then no other information given, right? But we can conclude from the diagram that we have a vertical pair here, right? We have two intersecting lines that form a vertical pair here and here. So we can say that these angles are congruent by the vertical pair postulate, and therefore we have side, angle, side congruent with side, angle, side, right? So both sides and their included angle, and so we can say yes by SAS. All right, and then number 7, here we have a side congruent with a side, another side congruent with another side, and then we have an angle with an angle, right? So we have two sides and an angle. However, this angle is not the included angle, right? And so we cannot use side, angle, side, because this would be side, side, angle, right? And if we listed it sequentially. And so side, angle, side, the angle has to be between the two sides. All right, so that doesn't work. So our answer would be no. They're not. They can't be proved congruent.